let's talk about carbon dioxide with electricity. So it's a little bit different than gasoline. So let's start with a little intro. When you receive your electricity bill each month, your usage is most likely presented in terms of kilowatt hours, so kWh's. A kilowatt hour is a unit of energy equivalent to 1,000 watts. So 1 kilowatt is 1,000 watts. This conversion we will use for almost every problem. Okay, so the question is, if we left a 100-watt light bulb on for 1 hour, what kind of kilowatt hours would we use? Well, we always start with the watts. So 100 watts, then we use this ratio. 1 kilowatt is 1,000 watts. When I do that, the watts cancel out. I'm left with kilowatts. Now, to get kilowatt hours, I need to multiply how many hours? Well, it says 1 hour. So if I multiply by 1 hour, I do the math, right? 100 divided by 1,000, I end up with 0.1 kilowatt hours. Well, the national average emissions factor for electricity is 1.37 pounds of CO2 per kilowatt hour. So our conversion factor will be 1.37 pounds per 1 kilowatt hour. So with gasoline, it was 19.8 divided by 1 gallon. Now we've got 1.37 pounds divided by 1 kilowatt hour. So therefore, the amount of CO2 emissions caused from leaving that 100-watt light bulb on for 1 hour is how much? Well, remember we did 100 watts times 1 kilowatt is 1,000 watts times 1 hour. So that right there gave us kilowatt hours. Then we multiply by 1.37 pounds per 1 kilowatt hour. Because kilowatt, hour, I'm left with just pounds. So when I do this, I end up with 0.137 pounds of CO2 for this particular problem. Now let's get into some of these and let's kind of do a little bit of comparison here. So we have the wattage for an electric oven is approximately 3,000 watts while a crock pot has 250 watts. For this first part, we're just going to calculate the kilowatt hours for cooking a chicken in the oven for 2 hours and a crock pot for 5 hours. So let's just do the crock pot. I'm going to need a little bit more space. So the oven uses 3,000 watts. Okay? We know that 1 kilowatt is 1,000 watts. So there's my watts canceled out. Then I need how many hours? So it says that the oven is 2 hours. So 2 hours. And this is just kilowatt hours. That's what we want. So when I multiply the top divide by 1,000, I end up with 6 kilowatt hours for my oven. Now when I use the crock pot, I have 250 watts. And again, 1 kilowatt is 1,000 watts. That allows my watts to cancel out. I'm using my crock pot for 5 hours, and that leads me to 1.25 kilowatt hours. Okay, so now that we have that, let's go to the next section. Well, think about your house. Your refrigerator, your oven, your air conditioner, your heater, they don't run constantly. They run when they need to. So we're going to reduce our calculations by 30%, meaning we're only going to run them 70% of the time. So 70% of what we have. So for the oven we have 6 kilowatt hours, but we only want to use that 70% of the time. So if I multiply that by 0.7, I get 4.2 kilowatt hours because it doesn't run the whole time, right? It'll heat up where it needs to be and then it kind of shuts off and lets itself cool. And then when it hits too low, it turns back on and kicks in. So it really is only working about 70% of the time. Now our crock pot, we were at 1.25 kilowatt hours. Multiply that by 0.7 for that, and our crock pot really is only using 0.875 kilowatt hours when you factor in that it's not running the entire time. Okay, so these are the kilowatt hours that we're actually going to use, these two pieces. So for the oven, how much CO2 are we really using in the oven? Well, if I have 4.2 kilowatt hours, and I do 1.37 pounds is 1 kilowatt hour, right? Kilowatt hours cancels out with kilowatt hours, and our oven uses 5.754 pounds. Okay, crock pot. Let's do that down here, the CP. The crock pot used 0.875 kilowatt hours, and we're multiplying that by 1.37 pounds over 1 kilowatt hour. So kilowatt hour cancels out with kilowatt hour, and the crock pot actually uses 1.19875 pounds of CO2. So you can see, making this chicken, it's kind of obvious that the crock pot is greener. You're using less CO2. So if you compare the kilowatt hours, if you subtract the 4.2 minus 0.875, you save 3.325 kilowatt hours, which is roughly 33 cents for most things. And you are saving 4.55525 pounds of CO2. If you subtract those two, you get your savings. So by using your crock pot, you're definitely greener. You're going to save yourself a little bit of money each time you do it, and it's healthier for the environment as well. All right, so we are going to do some problems, and you can get the wattages from the table in your book, but I'm also going to give that to you as we go through these problems here. So a single game console. Console uses approximately 50 watts. So how much CO2 is produced from using this for 5 hours? Well, you always start with the amount of watts. So 50 watts. As soon as you have watts, you change that to kilowatts by using the 1 kilowatt is 1,000 watts. Always. That's always your first step. Now that I have kilowatts, you got to think kilowatt hours. So we're using this for 5 hours, so I multiply by 5 hours. Once I have, you can see kilowatt hours, now we can say, okay, 1.37 pounds is 1 kilowatt hour. Because kilowatts cancels out with kilowatts, hours cancels out with hours, and I'm in pounds of CO2. So 50 divided by 1,000 times 5 times 1.37. This game soul is going to produce 0.3425 pounds of CO2 in 5 hours. How much CO2 is produced from ironing clothes for 1 hour a week for 4 weeks? Now, 1 hour a week for 4 weeks, that is a total then of 4 hours, right? Because you're using everything in terms of hours. Okay, so ironing clothes is 1,100 watts. And we're doing this for 4 hours. So we always start with what? Watts. 1,100 watts changed to kilowatts. 1 kilowatt is 1,000 watts. So that makes the watts go away. How many hours am I doing this for? 4 hours. Once I have kilowatt hours, I do 1.37 pounds is 1 kilowatt hour. Kilowatts, kilowatts, hour, hour. I do the math, and I end up with 6.028 pounds of CO2. So the nice thing about these electricity problems is they're all kind of the same. Watts to kilowatts to hours multiplied by the pounds. How much CO2 is produced from running an old refrigerator for a month, just 30 days, and assume it's not drawing power 30% of the time. If it's not drawing power 30% of the time, that means we are using it 70% of the time. So that's the good part. Okay, this old refrigerator uses 115 watts. Okay, so we start there. 115 watts over 1. By now you should automatically think, go to kilowatts. 1 kilowatt is 1,000 watts. So now I'm in kilowatts. Now, how many hours am I doing this? Well, it says for 30 days. So that's 24 hours in 1 day, and I'm doing this for 30 days. So the days cancel out, and that gives me 24 times 30. That tells me how many hours to do this. And then now we have kilowatt hours, so we can do the times 1.37 pounds is 1 kilowatt hour. Kilowatts, kilowatts, hours, hours. But don't forget that this is only on for 70% of the time. So once you get your answer, multiply by 0.7, because 30% of the time it's off. So multiply by 0.7 to get all the time, and this will be 79.4 pounds of CO2. All right, if someone sleeps each night with an electric blanket turned on for 8 hours for the 4 coldest months of the year, how much CO2 is produced? Now, You can do this 4 coldest months of the year a couple different ways, but I'm saying there's 4 months. I'm going to average 30 days in a month. That's 120 days. Okay, so electric blanket has 200 watts. So I start with my 200 watts. Yep, you're right. 1 kilowatt is 1,000 watts. So the watts go away. Now, how many hours? Well, it's 8 hours in one day, and we're doing this for 120 days. So that makes my days go away. Now I have kilowatt hours, so now I do the 1.37 pounds is 1 kilowatt hour. Kilowatt cancels out kilowatt, hour cancels out hour. I do the math, and I end up with 263.04 pounds of CO2. Number 5. How much CO2 is produced from running a dishwasher for 45 minutes? Okay, well, first of all, 45 minutes, if you think about an hour has 4 15-minute intervals. So 45 minutes is 3/4 of an hour, or 0.75 hours, right? Think about it in that terms of hours. Now, a dishwasher is 1,500 watts. Okay, so watts. Then 1 kilowatt is 1,000 watts. 0.75 hours. Now I have kilowatt hours. So I have 1.37 pounds per 1 kilowatt hour. So we can say watts cancels out with watts, kilowatts cancels out with kilowatts, hours with hours, and I'm left in pounds. So when I do that multiplication, I get 1.54125 pounds. Number 6, just 2 more. Number 6, what would be the CO2 savings from using a ceiling fan for 8 hours instead of a one-room air conditioner? So we're going to kind of do 2 problems, right? We've got the ceiling fan, which is 100 watts for 8 hours. Okay, so 100 watts, I do 1 kilowatt is 1,000 watts, 8 hours, 1.37 pounds is 1 kilowatt hour, right? Everything cancels out. I do the math. I get 1.096 pounds if I use the ceiling fan. Now, if I use the AC, which is 1,100 watts, I do 1,100 watts. 1 kilowatt is 1,000 watts. 8 hours. 1.37 pounds over 1 kilowatt hour. Everything cancels out again, and I end up with 12.056 pounds. So how much do you save? Well, 12.056 minus 1.096 gives me a savings of 10.96 pounds of CO2. So if you can get away with the ceiling fan, you're going to use a lot less electricity than that room air conditioner. Number 7, suppose the cost of electricity is 10 cents per kilowatt hour. What's the cost of using that game console for 5 hours? Recall from question 1, the game console was 50 watts. So if I go 50 watts, again I'm talking kilowatt hours. So 1 kilowatt is 1,000 watts, and I'm using it for 5 hours. Well, that gives me kilowatt hours. So if I'm in kilowatt hours, I want to do 10 cents per kilowatt hour. Kilowatt, hour. This puts me in money. So using a games console for 5 hours will cost you approximately 3 cents. And that is some problems with electricity and carbon dioxide.